Hello and welcome to ashford.com. You are watching an interesting video on researchers have identified 23 new genetic variants that significantly increase men's risk of developing prostate cancer. Please read this disclaimer carefully. In a large international study, scientists have identified 23 new genetic variants, differences in sequences of DNA, that raise men's risk of developing prostate cancer above the population average. Researchers have identified 23 new genetic variants that significantly increase men's risk of developing prostate cancer. Believed to be the largest meta-analysis of its kind, pooling data on over 87,000 men, the study reveals previously unidentified mutations for prostate cancer among groups of European, African, Latino and Japanese origin. 15 variants were identified among men of European ancestry, 7 were identified in multi-ancestry analyses and 1 was associated with early-onset prostate cancer, write the authors. Some of the newly identified variants have already been linked to other cancers. Together with 76 previously known, the new variants account for a third of the inherited risk of developing prostate cancer in men of European descent. And, because the mutations are inherited commonly among populations, they can surface in men with little or no family history of prostate cancer. All 23 of the variants, more specifically known as single nucleotide polymorphisms, or SNPs, pronounced SNPs, that the study identifies are to be found in regions of DNA that do not code for proteins. This suggests they are involved in regulating other genes rather than making proteins. The study authors, including 2 researchers from Johns Hopkins University School of Medicine in Baltimore, MD, report their findings in the journal Nature Genetics. Co-author Alan Pardon, a professor of urology at Johns Hopkins, says, inheriting any single one of these genetic variants has only a small effect on prostate cancer risk. However, a subset of men will inherit many of these variants, putting them at substantially increased risk for the disease, from 3-6 times the population average. He suggests men with these risk levels should perhaps be encouraged to have screening earlier. Fellow co-author William Isaacs, a professor of oncology at Johns Hopkins, says using these SNPs could serve as a molecular family history to enable better screening guidelines than traditional family medical history backgrounds, which can be difficult to pin down. Using the advantage of number power to find the variants. By pooling data from smaller studies, the meta-analysis has the advantage of number power, as Professor Isaacs explains. There is a power in numbers that helped us find new variants that were only hinted at in smaller study populations, especially among minority men, and as we found the same variants across several populations, the evidence became stronger that they were definitively linked to prostate cancer. All told, the samples included in the meta-analysis contained data from 43,303 prostate cancer patients and 43,737 men without prostate cancer. The analysis covered over 10 million areas of the genome looking for SNPs, where one sequence of DNA is swapped over for another. The researchers compared the scanned genome regions of prostate cancer patients with those of men without prostate cancer to find the 23 new SNPs. References